Greetings to everybody. Greetings to everybody who is with me right now. Welcome back to Shexa's YouTube channel. Please like, comment, share, and subscribe to this YouTube channel. Today we're going to talk about the stack. So today we're going to program the stack, and this is what we will talk about. We will define what the stack is, and we will discuss stack applications, where exactly the stack can be used or is normally used. Then we do the programming, where we apply the stack programming instructions and their functions. So we'll discuss their functions, stack programming instructions functions. And then we talk about stack programming syntax, and then we do it practically with code examples. So what is it that we call a stack? Stack is just an area of memory for keeping temporary data, including that involved in the operation of subroutines. So it's just an area. It's a named area. It's an area called stack inside the memory, and it's used for making subroutine calls, passing parameters and local variables. Stack is also used to control flow for x86 function calls. Like I think we've talked about this in the previous lecture, in one of the previous lectures, when we talked about procedures. Yes, I think that's the most recent one. When we talked about procedures, when you call a procedure, what happens? We've seen the stack being involved. So the stack is accessed using the stack pointer and stack segment registers. So those are the two registers that are used to access the stack. The x86 stack can be manipulated explicitly via the SP register. A 16-bit stack pointer implements a stack to support subroutine calls and interrupts or exceptions. Right. So let's now talk about the stack programming instruction called push. Push stores 16-bit value into the stack. That is, it pushes a certain value, a certain 16-bit value, onto the top of the stack. So push instruction pushes the values of the following registers on top of the stack. So the registers AX, BX, CX, DX, SI, DI, and BP registers. So these are the registers that are used as source. So we'll talk about the simplest or general syntax for push instruction. Right? So push instruction, it takes 16-bit value. So whenever you are dealing with a stack, you must know that the values that are pushing or popping from the stack are of size 16-bit, and the source could be of these of any one of these general purpose registers that are AX, BX, CX, DX, SI, DI, and BP registers. Right? And here's an important notice You must note that push works with 16-bit only. Like I said, push works with 16-bit values only. I think I've emphasized on this. And then push immediate. If you want to push an immediate value to the stack, it works only with the 8186 CPU and later. All the processors that were produced from 8186 up to the latest ones are the ones which can push immediate value onto the top of the stack. And the stack pointer is the one that points at the top of the stack. And here is the syntax for push instruction. The basic push instruction says you push from source. So source, you just put source, but we already know that you are pushing to the top of the stack. So you just say push, that's the instruction, and then source, that's the register that we are getting value from. So push reg, or we can say, and these are the registers that you can push data to the stack from. And then we have push segment register, and these are the segment registers that you can use to push data to the stack. And then we have this, you can push data from the memory. You know how to access memory. Like I said, whenever you see the square brackets, you must know that we are now accessing memory, and whatever that is within those brackets represents the effective address, which is the memory location. Right, so here are some examples of memory locations. Maybe bx, the value in bx, the value in bx plus si plus 7, 16-bit variable, and so forth. So if I am to ask you a question, which addressing mode would you have used if you are trying to push value that is from a memory address that resides at bx? Which addressing mode would you have used if you are trying to push the value that is residing at an address that is in bx? Okay, your answers, please, your answers, that's fine. I will give you the answer. It's based in the it's based addressing mode, because the register that we are using is base register. And then we have bx plus si plus 7. Which addressing mode is this one? 1, 2, 3, 4, 5. So this one is best indexed with displacement, right? So you can push immediate value. Like I said, if you want to push an immediate value, you must know that the processor that you are using is version 8186 or later. And these are the examples of immediate values. You may push 5, you may push minus 24, 3F, and that binary value. So here I just gave you these examples so that you know that we can push positive and negative decimal values. We can put positive and negative hexadecimal values. You can put push positive and negative binary values. So that's it. Let's now talk about how the push instruction works. So the push instruction works this way. We say push source, right? Like we said earlier. So push source, it does the following. And what is it that it does? It subtracts 2 from stack pointer register. It subtracts 2 from stack pointer register. Why? Because it's 16-bit. The value that is that we are pushing onto the top of the stack is of size 16-bit. And how many bytes are those? there are 2 bytes. So it writes the value of source to the address SSSP. So that's the address that we are going to, whenever we say push and then we put the source, we will be writing the value of source to the address SSSP. Right. Let's now talk about the pop instruction. Pop instruction gets the 16-bit value from the stack. It's now taking the value from the stack to a certain destination. So previously we were saying push source, so we are pushing a certain value from source to the top of the stack. But now we are saying pop, we are now popping the value from the top of the stack to a certain destination. Right, so here is something that is important, but we have talked about it already. Pop and push, they work with the 16-bit values only. And here is the syntax for pop instruction. You say pop destination. So a destination can be a register, general purpose register, and these are the registers that you can pop values from stack to. You can also pop to segment register, and these are the segment registers that you can pop values to. And then you can pop from stack to the memory, and these are examples of memory addresses that you can use to as destination to store the values that are being popped from the stack. And then here is how the pop instruction works. So the pop destination instruction, something like this, it does the following. What does it do? It writes the value at the address SSSP to a certain destination, or to the destination that is encoded in our program, in our line of code. And here's what happens. Instead of subtracting, it now adds 2 to stack pointer registers value, and then the current address pointed by the stack pointer is called the top of the stack. That is anything that is at the top of the stack is what we call, is what is currently pointed to by the stack pointer. Right, here is an example of what? Of push instruction. So what is happening here? What are we doing with these instructions? Push 1 2 1 2, we are pushing 1 2 1 2 onto the top of the stack. And then pushing, what are we pushing? We are pushing the immediate value. So which addressing mode is this one? This is immediate addressing mode. And then what's next? Let's just open the program and observe what happens when we run these instructions. Right, so here is the code. So we are pushing this value onto the stack, and then this value as well onto the stack. So the moment we push this onto the stack, this SP subtracts 2. We push this, SP subtracts 2 as well. We push that one, it subtracts 2 again, and again. So we are going to talk about this since we are only covering the push instruction on this line. Right, so we emulate our code and try to see what will happen with this code that we have. Right, so this is the code that we have, and these are our registers, and here is the stack. This is our stack. So we say if we run to say here, then 1212 is pushed onto the top of the stack. So this arrow or this angle bracket is the one that is representing what? The stack pointer. Officially, this is the one that is pointing at the top of the stack. But this stack now, it grows going downwards, and the top of the stack will be the one pointed by this stack pointer. So after running instruction called push 1212h, then it means it ended up we ended up with 1212 onto the top of the stack, and then we run the next instruction. Then 1234 is pushed onto the top of the stack and it's pointed by the stack pointer. Same applies 0012, same applies to quad 3. You get that? So that's the push instruction. Let's now go to the next slide. Right, I think something is happening in the background of this slide, so let me just edit it. So it's supposed to zoom in and then zoom out. So that's what happens. So here we are saying we have our stack with these values, we have our stack with nothing. Our stack is empty, in other words. So what we do, or what happens when we push? So our stack pointer SP is pointing to the top of the stack, right? And then here is what happens. I think this statement is well known. The current address pointed by the stack pointer is called the top of the stack. So this is called the top of the stack. We will go back to that code so that you see why this statement will be repeated in every slide from here onwards. It's just because the stack that you will see on the emulator, it grows going downwards, and this stack pointer will be said to be pointing at the top of the stack while it's pointing somewhere where we cannot call top. Right, when you say push 1212h, what happens? This is what happens. 1212 goes onto the top of the stack. And then if we say push 1234h, this is what happens. 1234h goes to the top of the stack and is the one that is pointed by the stack pointer, and this one moves on to the next weight of the stack. And when we push 0012, it goes to the top of the stack like that. So this is what happens whenever push instruction. You get what I'm saying? So that's the push instruction, and here is the program. We have talked about it, and I just want to show you what I was talking about. in terms of how the stack grows. So here we go, just wait for some seconds as it opens. Please give me your likes. Right, so here we have instructions, and here we have emulation. Right, so like we said, let's just see what's happening onto the stack. So here's the stack 1212, and this is the stack pointer, this angle bracket. Look at it, look at the value that it's pointing at. That's the value that is at the top of the stack. 1 2 3 4. This one is 01 02 is the next instruction to be executed, and 0012 is the value that we expected to see after executing that value. And we expect to see that after executing that instruction, we expected to see 0012 at the top of this stack. There, you see 3333 there as well. So that's how the push instruction works. And then we now talk about the pop code example. Here's the pop code example. So pop, how does the pop works? We already have these values with our stack pointer pointing at that value. Right, so what happens when we run the pop instruction? Let's see. Here is where we put our code, and here are our registers. You will see the moment we say pop. So this is push. It's supposed to be pop here. I think something went wrong. Let me just edit here and come back in a few seconds. Right, so here is an example for pop. We have our stack with these values. So the moment we run this instruction, you see the instruction coming. The moment we say pop AX, we are saying get the value from the top of the stack and move it into AX, like that. So 33 is now in AX, and then the stack pointer subtracts 2 and points to the top of the stack, which is now 0012, and then we run pop BX, and this is what happens. BX will get 0012, and stack pointer points to the next value, which is 1234, and then same applies. We pop CX, and then 1234 is popped into or moved into CX. Same applies with pop DX. I think it's now clear. And then our stack pointer points to nothing, which is what we still call the top of the stack. You get this? So that's pop code example. Let's now look at the actual code. Let's now look at the actual code. Right, it's just that previous code, but now we know that we know the push instructions. Now we want to concentrate on pop instructions, but we cannot concentrate on pop instruction without giving values to the stack. So you will see what happens here with our stack. right? So we put this value there and this one goes there, right? So our stack, we open our stack and then we put it there so that you can see it when you put it there, right? So when I execute this, you'll see values being pushed in onto the top of the stack, right? So now when I run this pop AX, check AX here, the value that is to be moved into AX is the one that is on the top of the stack. And which value is the one that is on the top of the stack? The one that is pointed to by the stack pointer, which is 3333. So what happens when this value is moved into AX? What happens is the stack pointer subtracts 2 and then goes to point to 0012. Look at that. It's now pointing at 0012, and in AX we now have quad 3. We run the next instruction. 0012 is moved now to BX, and our stack pointer subtracts 2 and points to the previously or the next value. The stack pointer is that one, the angle bracket. And then if we execute next, we expect it to see 1 2 3 4 into CX, and CX is there, and then single step emulation 1 2 3 4. Same applies on pop DX. We expect to see 1 2 1 2 in what? In DX. Here is our DX, and then we run it 1 2 1 2. So we are done with this instruction. So in the instruction that is to be executed, you can also see it here instead of seeing it here, but both are identical. These no operations instructions. So we are done with push and pop. I'm not sure that you appreciate the push and pop code examples, the syntax and how they operate, and when and where one can use the instruction, this stack and its instructions, right? So next is a push and pop code example. This is a simple code example which is just moving values into AX and values onto the stack. So let's execute this and see what happens. Right, so this is the code. So here 1 2 3 4 is getting into AX, and then the value in AX, which is 1 2 3 4, is pushed onto the top of the stack. Then 5 6 7 8 is moved into AX, and then the value that which is 1 2 3 4, the one that was pushed onto the top of the stack, is now returned back into AX. Let's just see that from this program example. Right, so that's that one, and this is the other one. Right, so AX shall have 1 2 3 4, yes, and then our stack shall have 1 2 3 4 at the top of the stack, yes, 1 2 3 4, that's fine. Then AX shall have 5 6 7 8, okay, yes, it's having that. And then our AX shall have 1 2 3 4, which is the value that is at the top of the stack, 1 2 3 4, yes, that's it, we are done. And then we move to the next. Right, let's have this question. Write in a LP that exchange the values of AX with the value of BX. So we're exchanging values that are in AX and in BX, and we want to use a stack to achieve this. So here we have our stack, and we have our register, and the registers are there, and the instructions goes. So what happens is that, let me go slowly. We have our instructions. So right, we move. Let me just edit this so that it doesn't rush through. Alright, so let me save this value, that. Right, let's just run it like that. So what happens is this. What happens is this. We have our stack, and we have our code, we have our registers. So when we move 1 2 1 2 into AX, it goes into AX. We move BX into that. Let's just treat this way. I want it to go slowly, but slowly, and giving me time to explain to you what's happening. Right, so let's try to have it that way. So this is what happens. We have, let's say we have the values, we have our stack, and we have values in AX and values in BX. And what we want to do is we want to exchange the value that is in BX. We want to, the value in BX, we want to put it into AX. The value in AX, we want to put it into BX. So what happens is we start by giving value to AX. We say, for example, move AX 1 2 1 2, meaning to say 1 2 1 2 is moved into AX, and then the value in AX shall be 1 2 1 2. Right, like this. We have 1 2 1 2 in AX, and then we say move BX 3 4 3 4 H, and then BX is now 3 4 3 4. So we want AX to have 3 4 3 4 and BX to have 1 2 1 2. So this is how we do it using the stack. We say push AX, and push AX will take the value of AX onto the top of the stack, like that. And then we say push BX, and then BX 3 4 3 4 is going to be pushed onto the top of the stack. 3 4 3 4 goes to the top of the stack, and then what's next? We now pop the value at the top of the stack into AX. We've exchanged, so it's more like we've taken the value of BX into AX, and then 1 2 1 2 goes to the top of the stack, and then we pop that value onto BX register. Then we are done exchanging the values of these two registers using a stack. So our aim here was to exchange the values of two 16-bit registers, but we use the stack as a temporary storage to say the values that you want to put there before, because if you put the value without storing it somewhere, it will override the value that is already in that register. So we store it there. From there we put it back, and then we store the other value, and then we exchange, just like that. So this is how it goes. And here what I've done is I just reduced the speed. So what I want to do next is I'll increase the speed so that you see what happens, but not that much. The speed is not that much, right? Here we go. So we have our stack. From stack we have our code. From code we have our registers, and here are the instructions. Move that, it goes that way, and then move bx, get that into our register, and then we now push. This is what happens with push bx. That's what happens. Pop ax, that's what happens. Then pop bx, that's what happens. So that's push and pop code example for you. An instruction writing a LP code which exchange the values of two 16-bit values. Right, so I'm sure now that you now understand the stack and how to implement it, how to use it, where to use it, and many more things that we have covered in this lecture. Thank you very much for being with me. Please don't forget to do the following. You like, after liking, you give me your comment. After your comment, you give me you help me with sharing my video links and content links, and then you subscribe. You tell your friends, colleagues, family members to subscribe. Thank you very much. Enjoy the rest of your day. Bye bye.